Dear students, firstly I will introduce myself, Professor Ashok Chaube, working as a assistant professor in electrical engineering department of S&D College of Engineering and Research Center, Yeola. Now there are many lectures are going to be held on the high voltage engineering. So in the high voltage engineering, we are studying now. We have now studied what we have studied. We have studied the breakdown in gases, breakdown in liquid, and breakdown in solid directly. We have seen the different pattern or different content of the breakdown in gases. We have also seen the contents in the case of breakdown in liquids and dielectric bond. Now in this lecture, in the last lecture, what we are seeing the generation of the high voltages and current. When we have started generation of the high voltage and the current, then this time firstly we have seen the generation of high AC voltages. Just we have seen in that case the cascade transform, resonant transform, different and the clock. We have seen the different methods of producing the high voltage AC, high AC voltages. Now in the last lecture, we have studied to how to generate high DC voltage. When we have to study the DC supply or DC, we have to study DC terms. Then this time there are two terms are very common. That is going to be the half wave rectifier circuit and full wave rectifier circuit. In the last lecture, we have seen what is the half wave rectifier circuit and what is the full wave rectifier circuit. Right? So now, in this case, we are going to see a half wave doubler circuit. Now, why it is going to be essential to study doubler circuit? Because when we have seen the half wave and full wave rectifier circuit, the voltage, DC voltage generated is always less than AC maximum voltage. It is not. But what we have to do, we have to go for the generation of the high DC voltage. So for this purposes, the doubler circuits are used. What is the doubler circuit? It means it is double the supply voltage that is given. Once the supply on the AC side you are given, the voltage available on the AC side is going to be double that, double of that one. So in this case, see here, what is the doubler? Voltage doubler. Voltage doubler is an electronic circuit that produces an output voltage that is double the input voltage. Just I have told you same thing. That is going to be double the input voltage. It is a voltage multiplier with multiplication factor 2. Why it is called as 2? Because what is the name suggests? Doubler, doubled. 2 to 4, 4 to 8. So it is called a multiplication factor equal to 2. The circuit is formed by an oscillating AC voltage. What are the requirements for that one? AC supply voltage, to capacitor, to diode and the load. Nothing more. To capacitor, to diode and the AC supply voltage. By simply this 4 or 5 components, we can simply design the doubler circuit. The input voltage is AC and the output is DC voltage with twice of the peak value of the input AC voltage. In some of the applications, heavy and expensive step-up transformers can be replaced by a voltage doubler. Where expensive step-up transformers will be very expensive, that can be replaced by the voltage doubler circuit. Now, when we have to see the voltage doubler circuit, there are two types of the voltage doubler circuit. Half wave voltage doubler and the full wave voltage doubler. Just in the case of starting, we have seen the half wave rectifier circuit and we have studied the full wave rectifier circuit. So in the half wave rectifier circuit doubler, the figure below shows a simple DC voltage doubler circuit. And it is clear that both the capacitors and diodes operate together to create the double voltage output. Just what I have told, there are no more components are required. It's a single supply, single base, it's a supply, two diodes and the two capacitors. These components are going to be double the input supply voltage, so it is called as a doubler circuit. See here the diagram. Here two diodes D1, D2, C1, C2, and here the output is going to be 2 values. See here, input waveform VCS maximum, but we are getting output waveform 2Vs maximum. Always remember that the value output at the load available or getting is somewhat less than 2Vs maximum because of the time constant of the capacitor and the time constant. Slightly less than 2Vs maximum that is available at the capacitor C2 here. Near about that one, but we can say that somewhat less than that is going to be the 2Vs maximum. So what happened? How it is going to happen in doubling circuit? See here, suppose the supply is given. So positive time, when supply is given for positive half cycle, this is going to be positive. See here. Here positive. What is D1? Positive is coming here, negative is coming here. It means it is going to be the forward bias. Remember that this is forward bias. So this is going to be the reverse bias. This is going to be the reverse bias. So in this case, what happened? Due to this one, this C1 is charged to maximum value, that is going to be 2Vs maximum. The supply which is charged up to 2Vs maximum. See here in the diagram also. We have seen that 2Vs maximum. Now we'll explain. Let's see here. Now we can go through the working of the half wave DC voltage doubler. All the positive half cycle AC sine wave. The first diode D1 is conducting. What I have told, D1 is forward bias conducting. That is the forward bias. It will charge a connected capacitor C1 equal to peak value of supply voltage DC at maximum. Right? Just I have told explain the same thing. There is going to be here. The capacitor is unable to get discharged due to the unavailability of the path, so it will remain fully charged. Which means what happened? Capacitor C1 will remain fully charged condition. Next, now positive half cycle, when AC supply is given, in the surely two terms, positive half cycle and negative half cycle. So we'll see what is happening in the negative half cycle. See here, next all over other negative half cycle, the second diode D2 is conducting or forward bias. In the first case, what happened? D1 is conducting, D2 is reverse bias. Now in this case, D2 is conducting and D1 is reverse. First diode D1 is non-conducting or the reverse bias. Due to this reverse bias, diode D1 will block the discharging of the connected capacitor C1. Reverse bias condition of the D1. There is no path available for that capacitor C1 to discharge. So what is going to be? It is going to be blocked. So the forward will charge the connected capacitor C1. Now what happened now in the second case? D2 is conducting. When D2 is conducting, what is the C here in the diagram? D2 is conducting. It means what happened? This is going to be the positive, this is going to be charged. Then C2 is going to be charged. In first case, C1 is charged. But C1 is not discharged because there is no path available for the C1 to discharge. So C1 is going to be discharged. Now what happened? That is due to the voltage across capacitor C2 will equal to 2 times the peak value of input transformer secondary voltage. That is going to be 2Vs maximum. 2Vs maximum. Throughout the next positive half cycle of AC input, the second diode D2 will open due to reverse bias condition. So the second capacitor C2 will get discharged through the load and the output voltage V output is less than 2Vs maximum. Otherwise, the two capacitors will be in the charge condition as said above. If there is a load, there is next cycle, C2 will get discharged again. It means what happened? We are getting the charge that is going to be less than somewhat, that is going to be the 2S V maximum. That is going to be the how we are getting in the half wave doubler circuit. The voltage that is available at a capacitor C2 is 2Vs maximum. That is going to be double of that one. So in the next lecture, we will see what is going to be the full wave doubler circuit.